I think in the interest of time, I'm not going to read the entire text. It's there if you need it. You want to refer to it after. Let's just talk quickly about constant positive velocity. Now, you just have a big blank space, right? Okay, so I'm going to draw. I guess I never really explained to you what ticker tapes are, have I? Let me do that first. So, have you ever heard the term ticker tape parade? Okay, do you know on TSN or on the news channels when they have the ticker? You know what that means? Like that thing across the bottom there where it says, you know, like bombing in Afghanistan, or they give you the, you know, the sport update, the game scores. That's called the ticker, right? Well, ticker tapes were. I've got one here. Mr. Friesen used to do it a while back. I don't bother, but okay, so this is ticker tape. It's just basically paper tape. Years and years and years ago, the stock, if you watch like CNN or something like that, no one ever does. They sometimes put the stock things across the bottom, you know? Okay, well, so years, like 1,000 years ago before computers were invented, if you wanted to know what the price of a stock was, you had to go to a ticker tape machine. It would print out, you know, every stock, it would print it, and then you'd have to wait like 20 minutes for it to come out again, kind of thing, right? And it was on this ticker tape. And so in New York, they would have like literally mountains of this stuff. And when the Yankees won the World Series, like they always did back in the 40s and the 50s, they'd have a ticker tape parade. And they'd parade the Yankees up Broadway Avenue, and the people in the business district would throw ticker tape out their windows because they had lots of it, right? And that was the parade. Now they use the colored confetti, you know, that you see sporting events, that kind of stuff, right? So it's, yeah. But that's where the ticker tape parade comes from. So anyways, you would hook up a card for this, and then there's a little device that makes a mark every second on the tape. Now, if the tape's moving at a constant velocity, what does the little marks look like? Evenly spaced. And we've sort of talked about this already, right? So can you draw that kind of thing? Okay? It's kind of like a ticker tape. There's a little object, and it's making little, I call them little turds on the little droppings, right? And they are evenly spaced, right? Don't use too much space because you're going to draw a graph underneath. So just put it across the top there. So this is constant positive velocity, right? How do I know it's constant, evenly spaced? How do I know it's positive? To the right, exactly. See, you guys know this stuff. What would the displacement time graph look like, do you think? Straight or flat? Well, they're different. Flat? Straight? Flat? Uh-oh.
He tricked you.
I did not. I was just making sure that I understood him. Yeah, I sort of tricked him.
You made it sound like
I don't ever, when I do that, don't assume that I mean that you're wrong. I'm just clarifying. You were right the first time, Graham. Straight. Straight. The straight slope indicates that it's moving at a constant speed. Okay, Graham, chance for redeeming yourself, my friend. Velocity time graph. So keeping in mind there's a difference between straight and flat. Velocity time graph.
I'm gonna stick with flat.
You're going to stick with flat because you said straight before, and then I got you to change it to flat. I'll tell you before you. Yeah, flat is right. How come flat?
Because it's not speeding up.
Because both, right? Because it's not speeding up. The velocity is remaining the same, and just like you said, it's not speeding up. The slope here is the same, however you want to think about it. Okay, Lane, seeing as your table there has had a pretty good roll, acceleration time graph. Are you going to ask the audience, like, is this like Price is Right? Higher, higher.
Flat.
Flat? You're right, but there's something special about its flatness.
Zero.
Flat and it's zero. Right? You're right, it's flat. But why is it at zero? Because the slope is zero. Now, is that important? Like if on a test, if you put it at 2, would I give you all the credit for it? Like, is the 0 important?
Yeah.
Yeah, it is. Here, does it matter what number it's at? The velocity time graph? Not really. I mean, if you've got no numbers, you have no way of knowing, right? So here it's not important, but here it is. Does that make sense?
Yeah.
Yeah? Good, lads? Yeah? Okay. So the next one is constant negative velocity, and again, I'm not going to go through the text. You can read it on your own. But what are the little turds going to look like? Going to be what? Exact same thing to the left. Right you are. Exact same thing, just to the left. Left meaning negative, right? Okay. Let's go to the other side of the junior high dance. Some answers. Ladies, what do you think? The displacement time graph. Straight? Straight or flat? Straight? But negative, right? Straight but negative. Down from 0. Why negative, Lane? Don't know? But why? Because it's moving to the left. Negative because it's moving to the left. Velocity time graph? Lance? I think. Velocity time graph. Your choices are, I guess what are your choices? Curved, straight, or flat? Flat? At a particular number? Flat is correct. But it has to be in what region? It has to be negative, okay? I would give you credit if you put it half and you put it at 0 or above, but to get full credit, it's got to be below, right? Why negative? Because the slope here is negative. Acceleration time graph? Flat at 0, right? Did you know that? Give yourself a silent pat on the back. Hooray for you. Positive velocity, positive acceleration. Positive velocity means moving to the right. Positive acceleration means acceleration to the right. Jenny, what's it going to look like? The little turds. Don't know? Positive velocity moving to the right. Positive acceleration. So, farther apart. Speeding up. Right you are.
Mr. Bennett, can you go back to the...
Sure, did I go too fast? Back to positive velocity, positive acceleration. Turns are getting farther apart. Displacement time graph. Curve, straight, or flat? Curve. Why curve? Because that's what indicates speeding up, right? The slope is increasing, getting steeper. Starting at 0, going up positive. Connor, what say you on velocity time graph? Curve? Straight. Remember, it's a graph of the slope, right? And so the velocity time graph, because the slope of this is increasing, we are graphing the slope. We are graphing the slope. Oh, that's one there. We are graphing the slope, so the slope is going up. Now, acceleration time graph. Flat line above 0, says Nick. Do you agree? Flat line above 0. Well done. Once you get into the swing of this, it's not too bad, right? You want to predict the next one. Positive velocity, negative acceleration. Moving to the right, but the acceleration is this way. The signs are opposite, so that means positive velocity. Moving to the right, but the acceleration is this way, so slowing down. Little turds are getting close together. Rabbit slowing down. What are the graphs going to look like? Dylan, will the DT graph be curved? Or straight? Or flat? It'll be curved? Curved is right because the velocity's changing. Will, you need to put the phone away, man. Listen, pay attention. It's going to be curved, but it's going to be, now because it's slowing down, that means the slope has to be getting steeper or getting flatter?
Flatter.
Getting flatter. Yeah, well, that's sort of part of the job. Getting flatter. Y positive. Y above 0. Moving to the right. Moving to the right. Okay, now what do you think about the VT graph, the graph of the velocity, the graph of the slope of this? How would you describe the slope of this? Is it getting steeper or flatter? It's getting flatter, which means the velocity is getting closer to 0, which means the graph has to approach 0, move towards 0. Do you have the picture in your mind? Was that the picture? Somewhat going towards 0. There's 0 right there. Going towards 0. This is slowing down at a constant rate. How can I tell it's constant? Because this is straight. Right? Which means the acceleration time graph, flat right flat below 0. Is the acceleration graph going to be anything but flat?
No.
Why not? Because the acceleration is either 0, flat, or constant, positive or negative. I told you, you will not see changing acceleration. I am not a jerk. Little physics joke there. Are we all good? Easy stuff, right? What's the next one? I seem to remember that there's one missing here. Maybe I fixed it, I don't know. Is there one on the back page? Do you have negative velocity, negative acceleration next? There might be one missing, I always forget. Yeah. Negative velocity, negative acceleration. So negative velocity means moving to the left. Negative acceleration means the acceleration is left. So this guy is going to be speeding up or slowing down. This time my speeding up, yeah. My reaction was indicative of your answer. Oops. Speeding up, but to the left. Speeding up to the left. Kind of wait. Because, you know, I'm not much of a joking guy. I'm pretty serious. Yeah, let me just get through all this, okay? Speeding up to the left. So, DT graph, as soon as the velocity is changing, that means the graph is? Are you trying to say curve?
Yeah.
Okay, good. Curved. But speeding up means that the slope of it is going to be getting flatter or getting steeper? Steeper. But which way? Is that what you had in mind? Is that what you were trying to indicate, Lane, with your hand waving? Okay, so if it's curved, the velocity time graph must therefore be? This is changing. The slope is going from 0 to steep negative. So it has to move away from 0 and towards more negative. And Will, what about that acceleration time graph? Flat below 0. You're right, you are. It's got to be flat. Easy stuff. Right? Now, how many people have in their mind, okay, I'm going to put all these on my cheat sheet. I'm going to stretch them all in one little corner. That's fine, but I think you burn up a lot of space. Negative velocity, positive acceleration. I think this is the last one, right? It's going to have to be flat, right? Flat below 0. Okay, the last one. Negative velocity, positive acceleration. Negative velocity means moving to the left, but positive acceleration means that it's this way, so this guy's going to be, when the signs are opposite, it is slowing down, which means it's curved, and the slope is becoming flat, negative velocity, so below, getting flat. Oops, I got to draw the picture first. Negative velocity, positive acceleration, moving left, slowing down. Moving left, negative, slowing down, slope getting flatter. Oh, they changed to blue, makes it easier to see. Is that what you had in mind? Velocity time graph. Slope is getting steeper or flatter? Flatter, which means the graph has to go away from zero or approach zero. Approach zero from which side? This is steep negative slope. Steep negative approaching zero. Steep negative approaching zero. Acceleration time graph. Positive or negative flat? Positive. Why? Slope is positive. Positive acceleration. It all fits together like a great big jigsaw puzzle. Observe the two cars below. You don't see them. Are they on your paper? No. Blue car starts ahead of the red car, which eventually actually starts off the screen. Oh, you know what? I shouldn't even ask that question. Let's just go right to the picture here. Okay, there's the blue car. There's the red one. Which one's going faster? Clearly the red, right? Can you? Is it either one moving at a constant velocity? Blue starts there. Does he? I think it's going constant speed, don't you? Each little tick mark every second, he's going like he's going 5 meters, right? Whereas the red guy's going.
No, blue one's slowing down.
Yeah. Oh, maybe. Okay. So what's the displacement position time graph going to look like for these ones? I don't know. Well, they say that it's constant speed. I can say constant speed because the graph is straight. Can you tell me from that graph at what time does the red car pass the blue car? How do you know? Yeah, exactly. They intersect right here at 7 seconds, right? They are in the same position at that time. Well done, whoever said that. They are at the same position at that time. 7 seconds. Now, how is that going to be shown? What do you think this next graph is going to look like? No. The next graph is, there's two cars on here, right? Red and blue. The next one is velocity time graph. Sophie, what's the velocity time graph here going to look like? Curved? Has the velocity time graph been curved at all? The velocity time graph has never been curved. So you just think I'm going to throw that in there? I heard someone say something. 2 straight lines? 2 flat lines. Which one above? Which one? Red will be higher but flat.
You're right.
Flat curve, right?
How come it doesn't start till 4 seconds?
How come it doesn't start at 4 seconds?
Oh, because it doesn't appear.
Yeah, it doesn't appear on the screen, right? Now, can you tell? Here is, if you know the answer to this question, you don't need to study tonight, because you'll know it all. Can you tell from this graph here when the red car passes the blue car? We know the answer, but the question was, no, we know the answer is 7. But the question is, can you tell? Is there a way to figure it out?
If you look at the top ones, they pass at 6 and 60.
No, 7 seconds, not 6. 7 seconds, yeah.
Well, every second the red car goes 20, so you can just see, you just do math, so red does 20 every second, blue does 5 every second.
Is there a way you could do math with just this graph?
Nope.
You do know the answer, by the way. You just don't realize it. How do you find position or displacement from a velocity time graph?
Take the 2 points.
Area. Area. Let me see if I can stop this guy here. Can I stop him? No, I can't. There's the blue. And there's the red. How do we find displacement? You have to find area. So you'd have to know where to look, but at 7 seconds there, that area there, I guess I should have done it in blue. That area there would equal, should those be the same? They should be. Would you know to pick 7 seconds? No. You'd have to pick like 1 second, figure out the two areas, compare them, pick 2 seconds, compare the two areas, compare them, and so on. It wouldn't be easy. If you go and you take honors, anyone taking advanced math maybe next year? Thinking about it? Mr. Ray will teach you about integration. Funny looking S signs. That's what they're doing there. Okay, I'm going to stop talking because I've talked enough today. How did those word problems go yesterday? Good, okay. Okay, so if you were away yesterday, I don't think anyone was, but if you were, I have a couple extras here. I have another set here for you as well. There I have a scan code on the back to try. Tomorrow, I can review, I can do whatever you want. We can do a little quiz. You tell me what you think we should do. Test this Thursday.
Help us review.
Yeah, I can do that. I should probably, you know what I should do?
Make a review for us.
I posted this last night. I don't know if anyone saw it. Did you see it?
I thought.
You got a notification. Were you excited? You're like, oh, I got a notification. Oh, it's just Schoology. That sucks. Did you say that to yourself? Okay, I posted this yesterday on Schoology, so it's there for you to go and look at. If you still haven't joined us on Schoology, you know, that's where all the cool kids are, so you should join. Here's what you need to know. Basic definitions such as mechanics, kinematics, dynamics, translational motion, variable motion, uniform motion, frame of reference. We talked about all those things. I'm not going to ask you to do them all. I'm just going to randomly pick 1 or 2. You should know what they are. You need to be able to convert from meters per second to kilometers per hour and back. Like one way or the other, right? What's the magic number? Got to have that on your sheet. And you got to know whether it's multiply or divide. You got to know which direction to go. You should be able to differentiate. That means tell the difference between position, displacement, and distance. Position is where it is. Displacement is how far and what direction. Distance is just how far. Differentiate between the terms an instant and an interval of time. An instant is a single reading. An interval is 2 intervals, right? Or 2 instants. Draw a DT graph from a written description. Johnny goes to the store on his bike. He slows down. On the way back, he goes faster. Draw a graph.
Multiply 3.60 and what?
You multiply when you go from meters per second to kilometers per hour. You're making the units bigger, so you multiply. Divide. Right to work. From a DT graph, determine displacement, average velocity, and instantaneous velocity. From a VT graph, determine displacement, average velocity, instantaneous velocity, average acceleration, instantaneous acceleration. Remember the 2-column pages? Basically everything on there. Recognize some ticker tape motion, the corresponding DT, VT, and AT graphs. Again, I realized last night, I haven't quite covered that. So literally, here's what the question looks like. There'll be little turds, and you have to tell me what the graphs look like. Recognize from a DT or VT graph the various types of motions. What I'm talking about there are variable and uniform. Uniform motion means moving at a constant speed. Variable motion means speeding up or slowing down. Solve problems with the kinematics equations. The stuff you're doing right now. When you put it all together, well, I was going to say maybe it's not that much, but maybe it is quite a bit, isn't it?
Yeah.
Yeah. I guess I have it in my mind because I've, done it 1,000 times. I found, when I was looking for those graph thingies, I found a lovely link here. If you click there, I'll throw that back up, but if you click there, This guy here, physicsclassroom.com, this physics teacher here has way more time on his hands than me. Here's basically everything we talked about. Right there, meaning of slope, literally everything, up to pretty much everything. If you need an all-purpose giant review, there it is there. Because I've got all these things open. Yeah, 20, come on. I'll close some. Okay, I'll be quiet now. You guys go work.